So not a huge number of people, I guess, in the audience are involved in building. And the reason I asked is that before I even really talk about the building, one of the things I thought about bringing today, but I was feeling a little too lazy, was to bring the actual documents for the building, because I think sometimes, especially in, that's fine, that's okay, presentations like this, I've got, about 45 minutes, minus some questions to talk to you. And it's hard to communicate just what's involved in a building. And I think people who are architects and engineers and contractors know the detail. But this building in particular had specifications that stacked about like that, 3 volumes plus some materials that were produced after the project went out to bid, and then 3 volumes of drawings. The building itself is 65,000 square feet, 3 partially 4-story building. And we are offering, if people are interested, to take a walking tour through the building after this. We can talk about details, but we can meet over at the building, which is at 6th and Gregory. So let's get started. As Gary said, I was involved in the project basically from schematic design. I wasn't involved in the conceptualization phase, the feasibility phase, but I came to the university in fall of 2003, and they were just about to get started with the construction documents for the project, and I was asked to be the project manager because I had expressed an interest in and really a passion for sustainability, and this was the campus's first project. So I've talked about the building a fair amount, both while it was in design and since then, and kind of tried to isolate some of the key things that were really, really important with this building to its success. And it is a successful building. And I think in the title of my talk, I am going to talk about some of the things we don't know yet about the building, how successful it is, remains to be seen in terms of some of the sustainability concepts for the building. Certainly its energy efficiency we won't know until it's been performing for a while. But the process itself, the design process, was an incredible success. So much so that at one point some of my bosses at the university essentially said, well, this was supposed to be a project that was kind of the benchmark. We were going to see how well we could do sustainability on the campus, and then we would make a decision as to how high to set the bar for the campus. And when the project design was all done, the bids came in good, the response that we got was, well, I don't think we're going to shoot for gold, which is what this building is attaining, because we think the project actually went too well. We don't think we can repeat that. And at first I was pretty horrified by that response. I thought that was pretty lame. But at the same time, there was some reality to that. The fact was that we had an incredible design team who were very committed. We had the sustainability committee behind us that was very supportive, that went well up the food chain at the university. And I think, we had an incredibly motivated user, the business school, and I'll talk a little bit about what motivated them. But the College of Business was highly motivated in terms of doing a sustainable building. And those are all things that those stars all have to align for this to have been the success it was. So, as Gary mentioned, sustainable design strategies were included really early in the project, from the beginning of their feasibility study. And a lot of the strategies that were included in that study were realized in the actual building. Now, in some cases, some things dropped off. There were some other things that got added later in the design process. And I think the other thing I'll talk about briefly is the clear and early benchmarking choice. In this case, LEED. And I guess, does everybody here know what LEED is? Does anybody here know what it is? Let's see. Does anybody not know what LEED is? Okay, a couple people. All right, LEED stands for Leadership in Environmental or Energy and Environmental Design. And it's a benchmarking tool that was developed by the U.S. Green Building Council, and it's kind of become the one of choice. There are a few other ones, but it's the one that's used, I think, more predominantly across the country. To be able to say a building is green, what does that mean? And they've kind of defined that. They've set some parameters. There's a checklist, and I'll kind of show that towards the end of my talk. For this project, what the checklist looked like. And it gives people a way to talk about all the aspects of green building. And in this case, they chose LEED, and then they chose initially LEED Silver. The campus, again, was a little hesitant, wasn't sure we could really target for our very first project anything too lofty. And so we were told to target LEED Silver. In the end, the project is actually submitting 52 credits, which if by some miracle they actually got all of them, they would actually achieve the highest level, which is LEED Platinum. But the chances are it'll probably achieve LEED Gold. And then I kind of highlighted the third thing, which is the integrated design process, which in our profession is something that's kind of bandied about a lot right now. And the way I describe it is that architects and engineers work in professions where collaboration is really important, but they tend to collaborate with each other within their disciplines and not so good across the aisles to other people that are involved in building. And this new idea, this idea of green building, which is, I guess it's not so new, but the new manifestation of it has a lot of emphasis on integrated design and the idea that you can't design a shell of a building and then come back later and say, let's make it green. What do we need to do? You need to be thinking about it from the very beginning of what is the building's function, how is it going to work, and where is it going to be, the site selection, et cetera. So you have to have all the players at the table. And that was one of the things that, Gary, when you called me a champion, that was probably the thing I championed the most, was I made the architects and engineers on the project and the people at the university work very hard. I made them come to all the meetings. I made them talk about the process, sometimes in meetings that they didn't think they belonged in, because, I'm not an engineer. I don't want to be sitting here talking about air handlers. Yeah, you do, because we need to have everybody at the table, and that was very important. And finally, consensus building. I'll talk briefly about that, but that was almost, if not as important as integrated design process, was building consensus, not just within the design team, but within the players at the university, because we did run into some resistance. There's in any institution this size you're going to run into, that's not how we've done it for the last 30 years. We don't want to talk about it. And yeah, we do. And so building consensus, helping people understand why they might actually have a stake in the building being green was really, really important. So I talked about the fact that we used LEED, and the fact that we considered design strategies early. I'm not going to dwell on that too much. In terms of the integrated design process, what I want to focus on there is initially just how many players were involved. Essentially, as I said, we had all the sub-consultants present for virtually all the meetings. We did regular review of what's called life cycle cost analysis within the project, and that was something the university required of them. But the team that we were working with was part of their modus operandi. And we made sure that the owner and occupants of the building, in other words, the facilities people and the business people, were involved constantly throughout the process. So there wasn't any chance that somebody could come back later and say, oh, no, we're not going to do that at the last minute. And we didn't actually have too much of that. If you work at the university, you probably know what kind of a behemoth this institution is. But just to give you an idea, these are some of the players that we had to integrate in our integrated design process. The University of Illinois at the top level included the Board of Trustees, the University Facilities Planning Office, I forget what their name is now, UOFPP, something or other. And then down at the campus level, the College of Business, all the players within the College of Business. And we really did involve all of these people. The dean was involved very heavily in the process. All of the director of the college facilities, the director of the college's finances, department unit heads, teaching faculty. We met with students. We met with staff support. Everybody that was actually going to be in the building at some point had a voice. Whether they got what they wanted or not was not always possible that it can please everybody, but they at least had a chance to hear about the project, and most people were pretty enthusiastic. Campus had a design review committee. I don't know if they still have that exact same committee anymore, but they were overseeing the project and looking at what the project was going to actually look like. And then the Committee for Sustainable Campus Environment, which is the one Gary was talking about. And then we drilled down a little bit further, and we had to deal with of course, folks with sites, with classroom technologies, with facilities and services, and all the people underneath facilities and services that includes. I was a project planner, there was a campus architect, landscape architect. I'm not going to go through all of this, but really all of these titles represent not just one or two people, but sometimes a whole group of people that we had to vet the design with. And then on the outside consultant side, our design team consisted of, and you'll hear when you hear people talking about the building, it's the Caesar Pelli, internationally renowned architect, designed the building. Well, they did, but they were the design architect. Then there was an architectural structural civil engineer firm, PSA, out of Peoria, that was sort of the architect of record. I guess they were the ones that actually held the contract. Mechanical, electrical engineers. Then there was an environmental consultant, a landscape architect, an acoustical engineer, lighting designers that we brought in that were specialized in sustainable lighting design. And then we actually, because we had certain things on this project that were so new to the campus and so, well, in some cases, sort of bleeding edge technologies as far as they were concerned, we had to bring in manufacturers. And we had a lot of meetings, particularly on lighting control, because we wanted the building to be as efficient as possibly could in terms of lighting. And for a classroom building, that meant a lot of lighting specialty scenarios and scenes. We chose to go with a low voltage digital lighting control system. And the university has never done that before on a large scale, and they were very skeptical. But if it works, it's a win-win for the university. It saves a tremendous amount of energy. It costs a lot less up front than the kind of programmable lighting systems that you get otherwise, the analog systems. And it saves just an amazing amount of energy. So we had to go through, again, if you work at the university, it was unbelievable how many meetings we had to have. First of all, to find the right person who could actually say, yes, you can do that. There's a thing with building ownership on the campus where if you don't follow the university's building standards, that's fine as long as the department understands they'll be paying for any repairs of that system. So if we did this digital lighting, the campus kept saying, well, that's fine, you can do that, but we're not going to pay for it. And of course, the College of Business didn't want to pay for lighting maintenance in perpetuity. But we did eventually we found the right person. He was the chief financial officer at FNS, and eventually we got approval to do it. I'll talk about it a little later in the talk. That's one of the systems we're still waiting to see if it's going to work, after all that. We had to bring in specialists for green roof design because that was something that the college really wanted, and it's a very visible green element of a building, but campus has never done them, and they were skeptical. And then the other thing that we've done on this building, which is new to the campus, is a displacement air system, and I'll talk a little bit about that later on. And then, of course, that drills down to, we actually build the building, all the people involved in that. We had people from a construction management team that were involved early on, not as early as they should have been. There was some feet dragging there, but and one of the things I wanted to show about this, so we got the construction management team, and then we've got all the contractors. There were 15 prime contracts on the project. And then there were subcontractors to them, just way too many to list. And out of this whole group, I meant to highlight this, the design architect, the environmental consultant, the lighting designer, and the lead specialist for the construction management team. That's about, 8 people total maybe that were directly involved in the project, actually had done a green building before. Everybody else had not. So this was pretty new territory and meant a tremendous amount of coordination. And the third key to success that I mentioned was the consensus building. And I guess the thing I've focused on there is that the university has some pretty high level of building standards in their building standards at facilities and services. So in some senses, it wasn't that hard to build consensus among the people that had developed those standards, because they understood that building buildings that are durable, that are efficient, are easily maintained is in the interest of the university, because it costs them money to do those things. Some of the ideas that they thought were kind of far-fetched, we were able to build some consensus with them by leveraging those existing understanding and beliefs that buildings need to be durable, and help them to see that some of the things we're talking about weren't really that far out there. They were actually going to make their lives easier. And sometimes we had to understand that the motivations for doing a green building were different across the board. For instance, the Business College, I think their main motivation was marketing. I think they understood that they could get donations to the project that they wouldn't otherwise get. I think they understood there was a real groundswell around green building across the country, and that they might be able to really inspire future students and the donors to the building, and it succeeded. That wasn't the same motivation that some of the people on the design team had, and certainly wasn't related to my motivation, but it didn't matter. We just understood that we were all going for the same thing. Our reasons were just somewhat different. The university puts designers through an incredible, a lot of work called their variance process. If you do choose to do something that's outside the norm, and we did a lot of things that were outside the norm, you have to submit verification of how it's supposed to, what it will cost. This is where that life cycle cost analysis comes in. And that challenged the design team to really prove that what they were asking the university to accept really would work. And the university does commissioning and inspection on all their buildings, and that helps because that's a requirement, it's a prerequisite for doing a LEED project that you have that. That means coming in and making sure that all the systems on a building are actually functional before you occupy. In this case, some of it's happening after, I think, and during the first year of occupancy. And then the building had to have a lot of energy modeling is required by LEED, but I think this project went above and beyond that, again, to sort of prove and build that consensus with the university, what exactly were we doing and how it was going to help the university and their bottom line energy consumption. And I think that component was probably the most telling in the end. There were a lot of skeptics about the project, and this is before the university encountered their huge energy deficit. They weren't yet sold on the idea that they really needed to be energy efficient. But I think this was compelling enough evidence that they began to see, yeah, maybe we need to go this direction. I'll talk a little bit about where they chose to site the building. This, I think, was kind of a given as far as its proximity to their other main building, Wohlers Hall, which is right here. This is the new site. It was a parking lot. I don't know what it was before it was a parking lot. I don't know if there's anybody that has institutional memory to tell me what it was, but it was a parking lot, and then next to it were some tennis courts, which got removed, and the parking got moved there. And the siting of the building, I think the one thing that there wasn't a lot of choice in terms of this building needed to sit on this site. It could have been a square. It could have been a box. There weren't too many configurations for the building, but the program for the building, I think, ended up dictating as much as anything what the shape of the building ended up being. This is a picture of the sort of what the first floor plan of the building looks like. It has this atrium space. It's a 4-story south-facing atrium in the middle, and then there's classroom and office wings on either side. On the first floor, it's mostly offices, and there's an auditorium on this end, which has the photovoltaics on the solar panels on the top. One of the early challenges that we found in LEED was that we weren't necessarily going to get all of these credits that you get in order to get a LEED rating on a building. But again, as sort of champion for the project, and I think the design team was embracing this as well, we sort of said we're not going to necessarily not do something just because we're not going to be able to do enough of it to attain a LEED point. For instance, and the reason I'm talking about it now is this site plan. To get one of the LEED credits has to do with restoring native and adaptive species on the site. And you have to do a certain percentage in order to get that credit. And early on in the project, the perimeter of the building was considered by the landscape architect, and I think some of the design committee people, to be sort of sacred, that, that prairie plant stuff is a little funky looking, and they weren't really sure they were going to be ready to see that on the front side of the building. They were okay with us putting it back here where we've got a bioswale and some sedge meadow and all native and adaptive trees. But on the front, they really wanted us to do lawn and hedges like they have around all their buildings. In the end, there was such a large groundswell at the university for this to be the most successful and green project that it could be, that ultimately the landscape architect for the campus came to me and said, are we going to get that credit? And I said, no, we're not, because we can't do this area around here. And they changed their minds. They said, okay, you can do it. So the building is in fact 100% as far as with a small one exception, which is there's a strip of grass along here, which is sort of a seating area for students, but it's actually narrower, I think, even than that picture. So they did end up getting that credit, or they will, I should say. This is one of the slides that the environmental consultant, which is a firm called Atelier 10, did for the project. And it was an early slide they created to help communicate some of the green building concepts for the project. This is a section cut through the main atrium space. And I think it was done, it did a good job of communicating how the building was going to function in real life. In other words, it shows some sun angles and how this really deep overhang of the roof here cuts off the summer sun. So that addresses one of the challenges that a lot of people had with this building, myself included, which is how can a sustainable building call itself self-sustainable and have this giant south-facing area of glass on it. I'm still waiting as far as, to be convinced 100% that this was a good choice. And I think that we'll see over time. One of the things we discovered was that in modeling the building, the peak cooling load actually occurs in November for this building, because once the sun drops, now the sun is actually getting into this space through that 4-story atrium, and there's a tremendous amount of heat gain. So the model showed peak cooling in mid-November, right about now. So it'll be interesting to see. They do some internal shading. The original design concept for the building had some external shading that would have helped with that, but that was something that the university didn't want to do. It would have been movable shades, and it would have been something that would have been a potential maintenance problem. They like to keep their buildings as simple as possible, and I agreed with that you don't necessarily want to put something outside of the building that's going to be a future maintenance headache for somebody. But it does beg the question, are they going to succeed? Now, one of the things that this picture does, though, is help to describe this displacement air system. And that will help with that phenomenon, I believe, that this heat gain issue, which is that down here where the people actually occupy that space is where the cooling and heating is delivered, down at the floor level. And that's not how it is in normal, modern buildings. Most of the time it's pretty high up, and that means driving the air at a much higher speed and at much more extreme temperatures in order to get that cooling and heating down to where the bodies are. So this is a really energy efficient system, and it hopefully will mitigate some of the problems in that area. The picture also communicates that in the office spaces they went with a more traditional mixed air ceiling delivery method, because this displacement system doesn't pay for itself or isn't as efficient in these kinds of spaces. Plus, the way you furnish smaller offices and stuff, it tends to make it tougher to have baseboard or lower level systems for air delivery. They did do the displacement in the auditorium, and they did it in all of the classrooms, though. So the building has probably, I think it's 3 different zone air handlers that distribute air. And this shows the photovoltaics are to be located on the top of this. There's a green roof area on this connecting link. And I think there's a reflective roof membrane, which helps with something called heat island effect, which is heat that gets developed around a building because of all the dark surfaces. And I think this slide did a really pretty good job of communicating all that. And it's a kind of picture that often doesn't get done for project, but this, as I said, this company, Atelier 10, I think understood that they needed to really communicate well to this client. These are some images. This one is a computer rendering of the common space, and this is actually a photograph of that same view of what that space looks like. And this is another slide cut through, a section cut through one of the classroom wings showing another area of green roof, and again, the classrooms that have displacement air offices. And then this was a beginning of a study about how the windows would function. They have operable windows in all classrooms and offices. That's another LEED encourages operable windows, and you get a credit for having them in the majority of spaces. One of the features on the building that didn't actually happen that shows up on this slide, and I think on a later one, is the light shelves. Let me go back to that. And it's a shame, I think, because I think it would have been very informative to the campus on the benefits of those. But it's just one of those things that happens on projects where apparently, and I've heard a couple of different versions of this story, they were included, they were in the construction documents. Presumably the university purchased them, but the design for them was somewhat lacking. There wasn't a lot of information. They weren't a purchased item off the shelf. They were, it should look like this, and the contractor bid it, but didn't really know what they were doing when they bid it, I guess. And when they submitted what they had planned to construct, it wasn't at all what the design team wanted, and the using group didn't want it, and they didn't like what it looked like, and it just ended up removed from the project. And I think that happened partly because all this great consensus building is wonderful, except people leave. I wasn't there anymore. None of the people that worked for the design architects were there anymore. They had all moved on to other jobs. The people were involved in the construction weren't aware of the importance of these, so they got eliminated. The good news is they did a lot of daylight modeling. This is another image that was done by the environmental consultant showing the potential for daylighting a good third of the room, the space in these classrooms with daylight, and they did end up putting in daylight sensors so that lighting is controlled. In other words, lights are turned off when the daylight is adequate in that portion of the room. And they didn't model light shelves. So, their idea was, we know it's going to work, and the light shelves should just add it. What light shelves do is bounce the light further into the room. But since they didn't use it in the model, the lighting is adequate the way it was designed. It just would have been even more adequate. So, and these, I'll kind of skim past some of these, but they did a lot of communicating about what different choices would mean in terms of energy delivery methods and lighting efficiency, and communicated that through these kinds of images to the campus in terms of making choices about systems.
What is the metric there?
I'm sorry. This is okay. This is actually describing what the benefit of daylight sensors in the offices will be. Now, that's just the offices. So recognize that this building is actually pretty classroom intensive. So it's just saying, should we bother to put daylight sensors in offices as well as, say, classrooms and public spaces? And what this shows you is that this is the design case with no daylight sensors. In other words, this was the baseline that you're measuring your energy efficiency against, ASHRAE 90.1. And the building, as its energy systems were designed, was going to give you 43% improvement over that. But to just add, let's see, design case only classroom daylight sensors, you could improve 1%. And then design case classroom and office daylight sensors, you go down another 2%. So they were basically showing you that the improvement of the energy, overall building energy consumption for adding daylight sensors in the classrooms, let's see, in classrooms only versus classrooms and offices, you went down 1% and then another 2%. And honestly, I don't remember if we ended up putting them in the offices or not. But I guess my question is, the baseline is the total building energy consumption? this is total building energy, and it's a modeled total energy consumption based on if you meet just at that time it was ASHRAE 90.1, 1999. So that's what if they designed just to that, which was I think at that time the energy code, what the energy code required, that's what the building would have consumed. And this is showing you essentially all the strategies that they chose for energy efficiency in the building brought that down by 43%. And then these are incrementally what improvements in the lighting, just the daylight sensor portion of the lighting. So this part includes the lighting improvements. In other words, the reduction of watts per square foot. But then this includes how much more you can save by adding lighting sensors. Is that making sense?
Yeah.
Okay. And this was another daylighting study for just the tiered classrooms. Unfortunately, this is kind of dim, but this is, again, showing you that light shelf that didn't happen. But the design for these windows was an interesting development on the building because it was a case where the integrated design process, I think, worked, one of the places it worked the best. The architect had already kind of envisioned what this facade was going to look like. They had sort of drawn images of what the window placement would be, and they didn't have these windows up here. They just had tall windows with some operable lights. And the environmental consultant came in and said, there are a couple problems with that. One is that in a classroom, you need to be able to darken the space in order to have projection. And if you darken the whole space, and in other words, if the window is floor to ceiling, then you have to close the shades as you do in here from top to bottom. But by breaking the facade up like this and having this element up here, not only can you have the majority of the windows blackened, but still have a little bit of glow of light, which shouldn't interfere with the projection the way they modeled it anyway. And then you can have this light shelf that would bring light deeper into the space through that. And they fortunately are located, the environmental consultant and the architect are both in New York City, and they would go to each other's offices, and they worked very collaboratively and eventually came up with the facade that the building design ended up with. And it's actually successful on both levels. It's quite beautiful. It's a much more articulated facade. It's got more, there's lots of nice architecty terms for it, but anyway, it's quite beautiful, but it also functions well, and it would have functioned even better if it actually had the light shelves. And then this is talking about the triple glazed windows. This is another element of integrating design that was brought into the project. These are an expensive window. They have a double insulated glass element, and then an interstitial blind component, and then another piece of glass that adds both energy efficiency and also keeps the blinds protected because they're inside the glass, so they stay clean and they're used and they're protected. But they're expensive, and so to determine whether they were a good fit for the university, they did a lot of energy modeling to see if there was enough payback just putting them in on energy. Unfortunately, the university's energy budget and their capital projects budgets are not connected. So the college didn't care if they were going to save energy. I mean, they did, but the dollars saved on energy in the future weren't going to impact their budget. It was something that was outside their realm. But what did impact their budget was what's called perimeter heat, which in the university's building standards is required at all windows and facades that have glazing. And so for this building, the red on this slide is where they did end up having to put in perimeter heat. But what you don't see along here at all the windows that are punched in this building and up multiple floors is perimeter heat. That in fact they were able to demonstrate through modeling that the improvement in the temperature inside those triple glazed windows was adequate to give you user comfort, which is really what the perimeter heat. It's a backup system, but it's also mainly there because of the perception when you're sitting by a glass facade like this. If you're too close to it on a cold day, it feels really cold, and you get a lot of complaints, which leads people to crank up the heat which leads to increased energy usage and system problems. So they were able to demonstrate and actually eliminate the entire perimeter heat system, which in turn obviously paid for the increased cost of the windows. So,
was that a variance that you had to apply for?
Yes. Yep. In fact, that's where these pictures come from, were slides that were done for that variance.
Was there argon in these windows anymore?
No, they're just airtight. So, yeah. And then this is another slide that was done by Atelier 10, just in early days, to communicate to some of the engineers in the facilities and services group how the systems were going to work. I'm not an engineer, but there was at one time in the early, I think this is one of the elements that was talked about in the feasibility study, was there was some discussion of having something called a labyrinth to supply the air, and that would be what it sounds like, a labyrinth with a buried concrete construction that the air flowing into the building goes through, and it tempers the air so that by the time the really cold air from outside comes through this labyrinth, it actually is not as cold and therefore doesn't require as much energy to heat in the winter, and vice versa, cool in the summer, because the temperature of the earth is much more stable. In the end, they eliminated that idea. It was very expensive, and by the time they'd made the building so energy efficient through insulation, good windows, displacement air, and all the other strategies that they chose, they didn't really need this element. And it certainly wouldn't have had a good payback because they'd already lowered the energy consumption so much. It's a concept that's been done by Atelier 10 on some projects in Europe. But, I think that it was a helpful tool to sort of think about what are the sources of energy consumption in a building system, and where can you realize the best performance and the highest savings. And this is another slide showing, I think it was talking about the outdoor air economizer unit, which ended up being a big component of their design. And it, with a dedicated no dedicated outside air and dedicated outside air. So again, I'm not an engineer, but these were demonstrating the differentials in making choices between systems that they chose for the building. And then this is a kind of playful little slide showing how a displacement air system works, where you deliver the air coming into the space at more moderate temperatures. In other words, when you have a space where the heating and cooling is coming from the ceiling level and it's a hot day, you have to drive 55-degree air or pretty cool air downward at a pretty high velocity to get it down to where the bodies are. And this way they could actually bring the air in at a higher temperature. It's at the temperature that you're trying to attain, and the bodies actually develop these sort of plume effect of driving the hot air and contaminants up to the ceiling level where they're pulled out of the building through the return ducts. More modeling stuff, and I think since I'm running short on time, I won't talk about this too much, but this is, again, modeling the mixed ventilation, which is the typical delivery system for forced air systems, and the displacement ventilation. And you can see it's not across, this is a month-by-month model, and it isn't across the board more efficient. And apparently in January, it's more or less the same on this model, but when you get into the summer months, you see some pretty substantial changes in the amount of cooling required. And this is showing you basically, I guess, 25% of the total savings for the building came through the displacement system. This is the green roofs, and one of the things that didn't happen on the building that was in the design was this portion of the green roof. There is green roof there, but it was intended to be that the university would be trying out two different systems. This one, which is the extensive green roof, which is if you've seen pictures from Chicago, most of the green roofs up there are of this type. They're a very low level of a thin medium, plant medium, with sedum type plants that spread out over the area, and they create a nice cooling effect on the building, but they aren't visually all that interesting. And they also filter water and so on, some of the other things that green roofs can do. Unfortunately, what happened here was, again, inexperience, I guess, on the part of the structural engineer. They they designed the beams adequately to support this deeper system, which is designed to hold more interesting plants, bushes and shrubs and flowers, and it was going to be a beautiful garden right outside these faculty offices here. But apparently they didn't specify the correct roof deck. And so apparently they came to the point when they were about to install some pavers up there for a little patio area and then this deeper roof material, and somebody caught it and said, no, that roof, the deck that's on there, and it was already on there, won't support that between the beams. So in fact, this is all the extensive type. It's the thinner material. And for those of you that go over to look at it, well, I think I have a couple of images of it. It's kind of sad looking right now. It's kind of, mostly looks like gray dirt. And this was another, I think, important lesson that the university is trying to understand, which is that after this building went up, which is the architecture building, there was a hue and cry about the horrible nature of having huge glazed facades on buildings, because this building performs very poorly. It's a west-facing glass with offices that are just like little bake ovens a lot of the year, and the energy consumption of this building is really high. And so when this building design first came to be shown, they kind of felt that they were going down that same path. But actually, because of the overhangs on this building, I think they were able to demonstrate that we're pretty sure this building will not have the kind of issues that building had. And then this is a LEED checklist. I think I won't go into this too much in detail. I think it's probably, if you know about LEED, then as I said, that the project is attempting 52 points, which is LEED Platinum. They in the sustainable sites, they did not, they couldn't go for brownfield development because they were not a brownfield site. And one of the points that we tried for that the university would not consider had to do with alternative parking arrangements. You can get a credit by having spaces available for alternate fuel vehicles or for van pooling or carpooling. And unfortunately, parking on this campus is a real political nightmare, I guess. And the parking folks they wouldn't touch it with a 10-foot pole. They just basically said, we have enough trouble, we have enough headaches as it is, we're not going to deal with it. I think in the future they will, but they just weren't ready on this project. But we did include things like bicycle storage changing rooms on the project, which is kind of a new thing for the campus, so that people that commute on bicycles have a place to clean up and change for work. And it's yet to be seen if those will be used. So that's one of the we don't know yet kind of things. And I think I've already talked about some of the strategies of restoring native planting and so on. They met all the prerequisites for the project. One of the things I think a lot of people don't know is that LEED has all these prerequisites, and one of them is environmental tobacco smoke, which essentially amounts to you can't smoke in a LEED building. I mean, there are ways to create completely separate air handling systems for a single space in a building. I think that they allow, but almost nobody does that. I already talked about that. They're getting almost all the water efficiency points for the project, and I think even possibly going for a point where they are even exceeding. So they're expecting to reduce water consumption over, again, the Energy Policy Act of 1992, which was the standard for the particular LEED that we were following, by 30%. They're looking at this point, I believe, 51% energy savings over ASHRAE 1999. Actually 90.1, 1999, which will get them eight credits for energy. And they're purchasing, as I understand it, again, because high-profile project and the College of Business really gung-ho about green, they're actually purchasing green power, which is another point you can get. And this is sort of an interesting one because it's not really specifically related to constructing the building. It's actually more operational. Do you want to pay a utility for green power? And they're actually doing that for, I believe, 2 years, where they're providing 50% of the electrical demand for the building through green power. The building has, will achieve the certified wood credit. And again, for those of you that come through the building with us later, there's a lot of wood in the building, and that means they've succeeded in obtaining a certain percentage. I forget what it is under this particular version of LEED, that the wood has been certified so that it's been through sustainably forested through the forest. I can't remember the term. Group that does it. And they also succeeded in getting credits for recycled content and for local and regional materials, and exceeding those to a point where I believe in their final submittals they're going for what they call innovation credits for higher levels even than LEED originally specified for recycled content and for locally and regionally harvested materials. Let's see. Oops.
The matrix, what does it mean? The left side 13, right side 2?
Oh, well, back up the top. Oops. Should have included that on the very first slide. This particular group did. This is their final version, I believe, before they submitted their sort of checklist of how are they doing. Early in the project, they had these high, medium, and low columns where they were pretty sure they could get. They were very confident they could get it. They would put it in the high column. If they were not positive yet, they would put it in the medium and low, and then NP is can't do it. Like I mentioned, the brownfield can't do. So this final one only has things in the first and second and last columns because this is after construction is almost done. So we know they're either getting it or they're not. There's no ifs left. So that's what those are all about. So those are just totals within the categories, those numbers at the top. So this last couple slides, this is a slide that just talks about some of the things that the environmental consultant told me in terms of the final outcomes of the building, that in terms, again, of the model of the energy consumption for this building, they anticipate 51%, or they did find in model form 51% savings in terms of energy cost, 47% in terms of actual energy use. I guess that has to do with the type of energy that you've actually saved. How it performs will be something that the university will measure over the next several years, but the model looks very good right now. The PVs are, now she had told me 4.7% of the building's energy, which will earn a credit. I think you have to earn 5% to get the credit, so I'm not sure what that meant, but those are not yet online. So again, another thing that we don't know is how well are they going to perform, and will they really perform to the level of, will they provide as much energy? The percentage that they provide is dependent both on how well they perform and how much energy the building actually consumes. So the percent, but the way you get the point for LEED has to do with how you model it, not how it actually performs. So I think it'll be really interesting to find out how it really does. This is a known that they did, manage to divert 83% of the construction waste from this project from landfills, and that's huge. I mean, the amount of construction waste that comes out of a project is gigantic, and prior to this project, the campus didn't really have any requirements for construction waste diversion, and they, a lot of the contractors that came onto this project sort of said, oh, there's nowhere to recycle stuff. We don't know anything about that. And luckily, the construction manager was pretty much charged with making sure they did, and there was a lot of communication about that early in the project. I think in my next slide I talk about some of the lessons learned that the contractor talked about. And I have some ranges on these recycled content, locally harvested things, because I got different numbers from the contractor than the environmental consultant. In other words, they haven't actually submitted that stuff yet, so they don't really have the final paperwork on it. But even if you just look at the lowest numbers there, nope, I think there we go. 15% recycled content is pretty good, and for a building, and at this point, a brand new building that isn't able to reuse materials from, let's say, an existing building when you're doing a retrofit, and 50 to 75% local manufacture, 40 to 70% local harvest is pretty impressive as well. if you're actually digging it out of the ground, in other words, like the stone on the building is a Minnesota limestone. It means it actually came out of the ground, or the trees were harvested locally. Within a 500-mile radius. Sorry. Yeah. Yeah. And yeah, I mean, it sounds like a large area, but when you consider how big the country is and the fact that, in fact, this building had a few things that, on the next slide I talk about, the contractor kind of complained about the fact that there were a few things that were specified in the project that came from Europe. And, the reason for this credit is to conserve energy, in terms of transportation, and also to support local, businesses. So local as in not that close. If it's Minnesota, we're not supporting our local economy, but we're certainly conserving shipping over. I think one of the suggested materials that the design architect, because they do projects all over the world, when we first talked about the building, just as a material palette concept, they mentioned some stone from Ecuador. And again, as the project champion, I said, not on my watch. We're not bringing in stone from Ecuador for a building in central Illinois. And then they got all of the low-emitting materials credits. Those are credits to reduce the amount of off-gassing of materials, paints, and carpet and flooring materials in the building. They got all of those credit. They have 60% of forestry service. Does anybody know what FSC? Forest stewardship. Yeah. Which is pretty impressive because again, there's quite a bit of wood in the building. And then these are actually the points they're going for in innovation, greatly exceeding these 3 different credits, and then doing green building education. And then they also, I better get going on the last slide. So these were some of the comments that the construction manager had, that there was a huge learning curve for the contractors because not one of them had ever worked on a green building, and they were unfamiliar with the paperwork, and they really weren't sure why they had to do all of this, and there had to be some pretty aggressive hand-holding and or penalties that were inflicted on the contractors for a while before they got the idea of particularly the recycling, and also that, for instance, they can't just come in, run down to Menards and grab the adhesives that they're used to using, or the caulking gun that they're used to using, and just come out and use it, because those are the materials that contain a lot of the volatile organic compounds. But they did learn, and over time they got the hang of it, and some of the contractors are now sort of the local experts because they can go on the next project and they've actually done it where their competitors haven't. And they did find recycling sources for most of the big materials, which is how they got the heavy materials, how they got so high. They did complain about the paper. This is a green building project, and they felt like they were cutting down an enormous number of trees to produce it because of all the documentation. And the U.S. Green Building Council is going to all online credit reporting now, so that should improve in theory. But we all know about, we were supposed to be in a paperless society by now, and that this hasn't really happened. They talked about communication being really important, that end users, first day in the building, they're feeling kind of chilly, and they brought in space heaters, and they had to explain to them that, well, you have your computer CPU sitting right underneath the thermostat in your office, so the heat coming off of your computer is telling the thermostat that it's warm in your space and you're freezing. But bringing in a space heater is not the solution. It's learning to educate the end users. The lighting control, as I mentioned, we don't know. It's working in the classrooms, but there's been talk that they may actually have to replace all of the ballasts in the building because there's a faulty programming element within the ballasts that were actually installed, and that's a real shame. I mean, that's a waste time and money. I mean, it won't cost the university anything, but again, we're dealing with new technology, and it's one of those glitches that you can't foresee, but isn't that surprising, I guess. And then there were some complaints about some of the things that were imported from overseas. There was actually a little bit of stone that slipped under the radar there. There's some accent stone on the building that was imported from India. And pretty much everybody on the project, by the time they found out about that, were pretty upset that something that heavy and large would be shipped, again, consuming a large amount of energy to be put on the building. And then there have been comments on the landscaping. Some people aren't that excited about the prairie look yet, and it will remain to be seen whether the grounds committees and workers on the university campus will actually maintain those as they need to be and not just come in the first year, dig them all up and put in sod when they don't like how they look. And I think I talked about some of the things, the light shelves being eliminated, the intensive green roof. One of the first times I walked into the building, I got overwhelmed with a pretty strong smell of chemicals. And so I think one of the things we had tried to talk to the university about was the need to invest in green cleaning products specifically for this building. And I think when they were rushing to get ready for the big grand opening, there was some really dirty stuff on some of the rubber in the stairwells, and that was where I smelled it. And I think they came in with their really high impact solvents and started cleaning ferociously to get ready for these events. And man, it was nasty. But at least that's a temporary. And then I think there's a problem where this was an element that was designed to be solid wood and got installed with FSC certified veneer, but it's already coming apart because it's a place where students put their feet, and it's vulnerable. And I think that's an element of sustainability that sometimes people forget, that, you know, it's no good for it to be a nice sustainable product if it's not going to last. And in this case, I'm not sure how that slipped by, because it's not. I did look it up in the documents, and it was supposed to be solid wood. So, and we don't know yet. These are not that attractive. That's the green roof as it looks today, and it's not going to do much over the winter. So. But I've seen pictures of green roofs that look like that, and within a year or two, they look pretty nice. They fill in. And there's the worker up there trying to get the remaining hookups on the photovoltaics on top of the auditorium. So, and that is it. So, are there any last quick questions, or who would like to take a tour? Yeah. Yes. Yep. It's connected to the. I'm sorry. What? All the steam and chilled water come from Abbott. Yeah. 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 It'll be measured, right? Yeah. That's, like I said, within the next year or so, I think the data will be coming in on the building and how it's performing compared to other buildings on campus. Anybody else? Yeah.
What is the expected return on investment of the community versus standard building?
Well, I think that's an interesting question. For this building, some might say it's almost immediate because the budget was set for the project, and we met that budget. We did put a lot of the green elements into the building as alternates because we weren't sure we could afford them, but they actually afforded everything. And sometimes when people ask that question, I can point out, for instance, on this building, one of the alternates they had was for Minnesota limestone, which is what's on the building, versus Indiana limestone. And it was purely an aesthetic choice. It's beautiful stone, and the Indiana limestone quarries are pretty well quarried out, and what you're getting out of there is not very attractive. The university spent an extra $1 million for that stone, for that Minnesota stone. It's beautiful, but it's certainly not any more sustainable than the Indiana limestone would have been. But having a beautiful building that people will respect and maintain and take care of is an element of sustainability too. As far as what they spent on mechanical systems, they were no more expensive than, the overall budgets for those. In fact, I think the contracts came in lower on those than they were estimated to be. Things like the photovoltaics. I mean, you almost have to look at an element like the photovoltaics, but the university got a grant for half the cost of those from the Illinois Clean Energy Community Foundation. So ultimately, the payback will be a lot better for the university than it really is, because the cost is being borne partially by that grant. I don't know if that answers your question, but I think that was scrutinized very, very heavily, and I think at the end of the day this is a high performance building, as are hopefully most of the buildings on campus, and to take it to that next level to make it green. In this case, yes, some things did cost more, but we worked pretty hard to make sure that balance happened, where the windows were paid for by the elimination of perimeter heat and so on. So, yeah.
So this is LEED certifiable, but not certified?
It's going through the certification process now.
And
so
what is that about? Actually checking all all these things?
Yeah, they basically have to submit paperwork verifying, that's where they were talking about the stacks of paper. It's all becoming electronic, but, and you don't, in the early days of LEED, you submitted, paper, a shelf full. Now you mostly submit, what are they called? They're basically letters that say, yes, we've met this. And you have the engineer signs off on it, or the contractor signs off, and it says, yes, we met the recycled content material. And then LEED actually audits credits. They'll audit a certain number of the credits, and you have to have the backup paperwork to submit for it. So you don't necessarily automatically submit that backup, but you have to have it. And so in other words, you have to have all the documentation for all the materials on the project that certify the amount of recycled content, and then that's collected on a spreadsheet that defines exactly what percentage you achieved. But all you submit to the U.S. Green Building Council is a paper that says this is what we achieved.
But nobody actually comes to see if there's any installation in the wall.
I don't think there's too much site inspection. I don't know, Christine, have you ever been involved in a project where they? No. As I understand, though, the review of LEED credits has been the USGBC doesn't actually do it themselves anymore. They have consultants that do it. And from what I've heard on this project, the consultant that's doing it is scrutinizing this project more than any that this environmental consultant who's doing all the submittals has ever encountered. So this project's being vetted pretty carefully, and they're arguing about the energy model and all kinds of things. Yes.
Can I ask the average construction cost for such a sustainable building?
The average construction cost.
Per square foot?
I don't think you can talk in terms of average. Yeah. I think that there's been some really good studies on the cost of LEED buildings, and what I like about them is that they show that there are buildings that cost $400 a square foot that attain LEED. There are buildings that cost $400 a square foot that don't come even close to being sustainable. Their choices was to spend money on marble from Italy. There are buildings that are $110 a square foot that are LEED buildings, but it's building type, it's what are the finishes, or what are the function of the building. So it's pretty hard to say. And this building, I haven't done the math recently. The total building budget for this project was $62 million. Of that, construction was, I believe, 42.5, so actual construction dollars. And then there's all the fees for the designers and the construction managers, and then the university has internal fees. They charge themselves for certain kinds of energy consumption. They're just, that's where the extra $20 million came from. So, but the cost is certainly a big question that's out there. Yeah.
It's related to cost. So what's
Yeah.
the percentage of private funding versus university funding versus state funding and grants?
On this particular project?
On this project,
Okay.
and is that a possibility for future buildings on campus, or is this a special, showcase project that the university was able to get a lot of support for?
Right.
Because of the business college,
Mm-hmm.
the state funding to do something?
Well, the state hasn't funded any projects in a long time. I don't remember when the last time they actually. Yeah, no. There's no state money in this project.
No, I meant
Yeah.
this.
Oh, this building. Yeah. The governor hasn't released money for actual projects in years. So this project is almost entirely funded from donors, although I guess, I don't know, there's some funds within the university. It was not always clear to me where all the money was coming from every day, and I was managing the budget. In fact, so to answer your question, after what just happened, in our country with the markets, and a lot of the people that gave money to this project don't exist anymore, or, maybe they do, but, they probably aren't giving a lot of money to projects today. Will we make a recovery to the point where they will be in the future? I hope so, I think this project's a pretty amazing, that it actually came off. One of the most stressful things about my job was that I was supposed to be managing the budget, and I was managing a $62 million project budget that didn't have money until about, a month before it actually went to bid. And, you're not really supposed to put that stuff in the computer unless there's actually money to back it up. But they kept saying, oh, it's fine, it'll be fine, you know. And it was, but, you know, there were a few sleepless nights. Anyway.
And grant money?
The grant money, really, that photovoltaic grant was the only one. That was $186,000. So not a huge chunk. The grant for the photovoltaics was $186,000. Yeah. You know, I don't remember off the top of my head. That was half of the cost we estimated for that. Yeah. And I don't know what the final. Actually, that's an interesting question. Is what did that part actually end up costing? I can find that out, but I don't know.